Hello, friends, and welcome to this special edition of the GraphQL Berlin Meetup. This is a special edition because we joined forces with GitHub Africa to bring you this session. I'm host Alex, and today we have two speakers, very special. Our speakers will be Eli Perkins, his presentation, Unlocking Static Type Superpowers with GraphQL Introspection, and myself on a talk, Type-Safe GraphQL APIs with Prisma and Nexus. And we had another speaker lined up for you today, Kudakwashe. However, he was feeling unwell and won't be able to join this meetup, but stay tuned and host him in future. So in this meetup, we have a raffle and we'll be giving out a copy of Designing Data-Intensive Applications by Martin Kleppmann. If you would like to participate and win a copy of this book, submit your email in the form that will be dropped in the section. So without further, it's time to introduce our first speaker, Eli. So Eli is a mobile engineer working on GitHub for iOS. Sorry for that mishap. Eli has been working with iOS since 2010 and has a passion for pixel perfection and loves to teach computers to solve problems so that humans don't have to. When he's not writing Swift, GraphQL, or Ruby, you will probably find Eli brewing coffee and hanging out with his chatty Siamese cat. Without any further delay, I bring you Eli.
Hey, how's it going, y'all?
The going
Awesome.
is good. How are you?
Doing well, doing well. Happy to give this talk. I'm super excited to chat a little bit more about how we've been using GraphQL introspection at GitHub to build some really great tools
Mm-hmm.
and to ship really great, awesome products to our developers.
Awesome. I'm looking forward to the talk. Are you
Cool.
ready to present?
I believe so. Let me share my screen real quick and we'll get started.
Cool. Adding it to the stream. Awesome. Take it away.
Awesome. Let's do it. Well, thanks for joining me, y'all. This talk's called Unlocking Static Type Superpowers with GraphQL Introspection. I'm Eli Perkins. Like Alex mentioned, I work on GitHub for iOS. I'm on the mobile team here at GitHub, been here about a little over 2 years now. And I'm excited to talk a little bit more about some of the fun things that we've been working on. GraphQL has really enabled folks to build some fantastic products by allowing developers to query for just the properties that they need when they need them. We often learn how to work with a given GraphQL server by using tools like GraphOL to explore the schema, or downloading the schema directly to use locally with other tools like Apollo's CodeGen or GraphQL Code Generator. But what is it that we're really downloading? How is it that GraphOL or Apollo Explorer or other tools know exactly what fields are available on each type? When we download a GraphQL schema, how did the server put together that schema for us? What is it that it actually did there? And how do the types from a GraphQL schema get turned into types in, say, TypeScript or in Swift or in Kotlin or in Java or other type-safe languages? And if other folks have built cool things like these in the past, what cool things can I build with a little bit more knowledge about GraphQL schemas, about GraphQL types, and more? At GitHub, we really enjoy digging into the nitty-gritty of GraphQL. We use GraphQL to power how developers across the globe connect, whether that's on github.com or on GitHub Mobile, or through third-party developers like you who use our GraphQL API to build new technologies and communities. Today, I want to dig into a really interesting topic, taking a look at GraphQL introspection and how the type system defined within GraphQL can be leveraged to solve problems in a unique way. We'll dig briefly into how GitHub CLI uses introspection at runtime to serve not only our customers on github.com, but our GitHub enterprise users as well. And lastly, we'll take a peek at how using introspection and GraphQL schemas as an input to other tooling helps our mobile team ship new features to many customers automatically. So let's dig in. What is GraphQL introspection? GraphQL introspection is how we ask a given server about its schema, and how we ask that schema about its types, its queries, its mutations, subscriptions, directives, and more. Introspection quite literally means examining, or observing within. So with GraphQL, introspecting is no different. We look within to see what's inside of a given server, what's inside of a given schema, or what's inside of a given type. There are two main ways to do introspection with GraphQL, and both of them involve querying a GraphQL server directly. Schema is how we introspect GraphQL server from the root of the server. Think queries and mutations. While type is how we ask a GraphQL server about one specific object or one specific interface at a time. Note how these two fields are prefixed with two underscores, indicating their almost private nature. Let's start by taking a look at the schema field. The schema field gives us an entry point into our graph. Asking the GraphQL server for its query type will offer up the type that our whole schema can be queried against. This might seem obvious at first. We write a lot of our queries starting with the query field. Similar fields for mutations and subscriptions also exist, defining the core groups of ways that any given developer can interact with a GraphQL server. The schema field also allows for asking a GraphQL server for all of the types that it has to offer. This is the bread and butter of GraphQL after all, defining the types along the graph. This is what gives us our type safety as we're developing applications. Further information beyond just queries and mutations can also be fetched from via introspection as well. Perhaps your server defines some unique directives that can be used within your GraphQL queries. The directives field on the schema will let you know exactly what directives are available for you to use with a given server. Here's an example of hitting the GitHub GraphQL server to get the include or skip directives, knowing that we can execute these against the GitHub API server. That's just a brief overview of some of the properties that exist on the schema type. Now that we've grabbed a list of all of the types that our server supports, let's poke a little at one single type using the type field. Type allows for querying one specific type, given that you know the name of that type already. In this example, we can query against the repository type and see what is the description of that specific type. Types include fields as well. Now we're starting to see how the graph is actually built up. Here we've queried for all of the fields available on the repository type. It even let us know which fields will be non-nullable or nullable as well, beyond just the scalar type that backs that field. Types can also include descriptions. This is how GraphQL is able to self-document the types and the fields that it exposes by baking the documentation into the query language itself. So that's our 2-minute tour of the two of the entry points into GraphQL introspection. But there's one more introspection field that you might already be familiar with and might be using today. And that's type name. Type name exists on every object within the GraphQL schema. You might have used this in the past to determine what the concrete type is of an object that you've received, perhaps from a union or from an interface. Fun fact, since schemas are a type as well, we can query for the schema field that we started taking a look at with the type field as well. Supplying that __ schema for the type name here brings us right back to the type that we started looking at. I could dig more into each of these types going field by field, but I'm not here to read documentation to you. I want to show you some of the cool things that you can actually do with introspection. Now that we know a little bit more about how to ask a server for its types, let's come up with some questions to have about a GraphQL schema itself. Given that we can query for all types against a given schema that a server supports, let's ask the GitHub GraphQL API how many different types that it exposes. As of this talk, that number was right around 1,182. This is using the GitHub CLI to query against this. A great way to execute queries quickly from your command line. Or perhaps that you want to dump an entire GraphQL server's schema. You could build GraphQL 2.0, or perhaps an app to explore GraphQL schemas in VR. We could write a recursive query ourselves to ask every type for all of its fields, and all of those types fields, and all of those fields types, and all of those types fields, and so on and so on. But much of the GraphQL community has settled on this specific query for introspecting the entire GraphQL schema. within the GraphQL JS reference implementation on graphql.org. The query itself isn't too complex, honestly, coming in at about 100 lines of code, give or take a few conditionals. Executing this query will give you all information about every type, every mutation, every query, every directive, everything about a GraphQL schema. Running it against GitHub's GraphQL API is no joke. This introspection query returns a lot of information, maybe too much for a human. But now that we've seen all of this, let's start putting this type system, these type definitions, this data to use, using computers. Here's one of my favorite classic examples of how we're using GraphQL introspection at GitHub to help our developers out. We add things to our GraphQL schema, tweak things, deprecate things, a bunch. Sometimes weekly, sometimes even more. One way that we help keep developers informed about these changes are through the changelog published on our docs page. This calls out new GraphQL fields that get added as soon as they're deployed. So how does this work? The process for this is publicly accessible within our docs repo and is essentially a two-step process. Every day, our docs repo kicks off a GitHub action workflow to run this process. It starts by downloading the current introspection from our GraphQL API and comparing it to the previous one that the workflow last ran against. It uses the diff of these two schemas, the previous one and the current one, to find additions, deprecations, to indicate feature previews or other upcoming changes. All of this is powered by dumping the GraphQL schema via GraphQL introspection. Since GraphQL schemas are data and types that we can work with, determining the difference between two schemas is no different than diffing two objects or two JSON structures. With a little bit of code, we can teach machines how to help us humans how to build better products with GraphQL. So far, we've looked at how you can query a GraphQL server for its whole schema, or how a developer might poke at a specific type. We might be familiar with downloading whole schemas to do some work on with them, but let's dig in a little bit more. Let's take a deeper look at some other ways that GraphQL introspection might be helpful as a more precise tool during the runtime of an app. GitHub CLI brings GitHub right to your terminal. A good chunk of GitHub CLI relies on GraphQL to fetch the data that you need about a given pull request or to submit a review for that pull request that you just reviewed from your terminal. At GitHub, we love GraphQL, and the CLI gives me my favorite way to access our GraphQL API with ease. It's one of my favorite ways to quickly query our GraphQL API, handling authentication for me, or even giving me a convenient way to connect GraphQL API requests or other data within command line tools that I use on my day-to-day. One feature of the CLI that's quite neat is the ability to see the status of all pull requests on a repo. This includes things like showing the status check state, whether my CI checks are failing, as well as indicating PRs that are open, as seen in green here, or in draft, as seen in gray here as well. A GraphQL query to fetch this information is pretty straightforward. We can ask the graph for some properties, pulling out the draft status, as well as PR status checks from the commit. These features were able to be added to our CLI quickly and efficiently, thanks to GraphQL and GitHub's GraphQL API. By adding the isDraft field to our query, I've got just the data I need to get going. However, if I ask our GraphQL API for some field that doesn't exist, things start to get ugly. Perhaps I want to see if dark mode is enabled for a given PR. If this field doesn't exist on my type in my schema, my query is not going to be happy. Errors like this lead to no data coming back, as the query cannot even be processed by our servers, meaning our resolvers don't even get a chance to run. This can lead to really tough issues for our users. If we as developers write invalid GraphQL queries, our users will end up with blank screens, errors, or even crashes at runtime. Issues like this aren't so uncommon for us here at GitHub, but we've looked on how to try to fix these. When we develop new features, It's often easiest for hubbers to develop against github.com, or what we lovingly call the monolith or .com. Using code spaces, any developer can get their own mini github.com up and running to develop against, emulating a similar environment as to what will end up in production. However, GitHub Enterprise is one of the best ways to bring experienced developers that developers know and love to enterprise scale companies who need more security, like VPN access or on-site databases. Just because a new feature we've built works against github.com doesn't mean that it will work against GitHub Enterprise right out of the box. This product has a different release cycle, and some enterprise organizations might not upgrade their own servers very often. As such, we need to build our apps that talk to GitHub GraphQL APIs with a long tail of releases in mind, supporting all of our customers, not just those on github.com. So how can we leverage GraphQL introspection to do that? One awesome way that our CLI team came up with is dynamic queries. By executing a GraphQL introspection request for only specific types, our CLI is able to determine if a given server supports a specific feature or not. It can dynamically change the query that's executed in order not to throw errors at runtime. By removing fields that are unsupported by a given GraphQL server, we can avoid executing queries that we know will fail at runtime. This also has the upside of supporting future versions of GitHub Enterprise as well, which might support these fields in the future. Within the CLI, a request for the fields of a specific type are requested using the type field on our schema. In this case, we've asked the commit and the pull request types a little bit more about the fields that they support. We can check to see if isDraft is in here, or if the status check rollup field exists as well. Since this returns all fields that these types support, we can look for specific ones that we're about to query for in the list of fields that are returned. On github.com, these fields should always exist, so we can query for them no problem. And on GitHub Enterprise, we can omit these fields from our query, allowing this query to be executed against these servers without throwing errors for undefined fields. Where before these fields might cause errors, using dynamic queries and introspection, we can omit them if the server does not support them and allow our queries to succeed without error. There are several different commands within the GitHub CLI that use this approach today, using introspection as feature detection, enabling the CLI to gracefully degrade its feature set when a given GraphQL server might not support that feature. It's a really great concept, and I encourage you to go take a look at it. So we've talked a little bit about how a schema from introspection can be used directly, and about how introspection can be used at runtime as feature detection. But I want to talk about one more thing that we've actively been working on within the mobile team. GitHub Mobile is the perfect use case for GraphQL. By requesting just the information needed by the app, we can save our users bandwidth and cell phone batteries with GraphQL, executing slim, efficient queries. Our mobile team loves GraphQL too. Here's a quick overview of all of the queries, mutations, fragments in the iOS app. The lines between fragments are shared between queries. You can see there's a lot of fragments shared within our code base, mainly due to core components like user list items or repo list items appearing in many places within the app. That's a lot of GraphQL here. And similarly to the CLI, our code base supports GitHub Enterprise Server as well. Our original implementation of this within the mobile apps was to support GitHub Enterprise Server a bit naively. We duplicated queries as needed for GitHub Enterprise. However, at times this meant duplicating entire trees of queries and fragments, which created a lot of code, maybe too much code. Our mobile team has been using Apollo on both iOS and Android to help turn our GraphQL queries, fragments, and mutations into executable Swift and Kotlin code. The type safety that Apollo gives our code bases has allowed us to build features rapidly and safely, but it hasn't been without its downsides. Let's take a look at one specific example. Using Apollo for iOS within the code base looks something like this. A developer writes a query for their feature using plain old GraphQL syntax in a .graphql file. Apollo's CodeGen tool uses the GraphQL schema to turn that query document into Swift types, allowing that query to be executed and parsed with type safety. Our developers then use the code generated by Apollo to build their features. Pretty straightforward. However, if we end up targeting multiple GraphQL schemas and have multiple GraphQL documents for each schema, then we end up with not only multiple GraphQL files too, but also multiple Swift types, which then themselves can sometimes be duplicated. This leads to developers hacking together some sort of semblance of versioning by appending version names to the query. It's not great. It worked fine for us to get the initial support of GitHub Enterprise out to our customers and unblock them from using the mobile app, but I think we can do better. Just like our CLI counterparts, we had to consider how to gracefully degrade the app when a given GitHub Enterprise server didn't support fields that we might be querying for on github.com. However, unlike our CLI counterparts, given the number of queries that our app makes and how our codebase utilizes fragments to co-locate data requirements for their views, doing introspection checks at runtime from our users' mobile devices on mobile networks didn't seem like a scalable solution. We'd be spending a lot of battery and a lot of our customers' data on their mobile devices to do these runtime checks. We reached for a tool to help us, one that we had already been using internally for GitHub for some time, and that's GraphQL Ruby. GraphQL Ruby is a Ruby gem with a fantastic set of bindings around GraphQL ASTs, resolvers, GraphQL primitives, and other GraphQL utilities. GraphQL Ruby is what we use to power the GitHub GraphQL API. Ever fired off a GraphQL request to a GitHub GraphQL API? Yep, that response was powered by GraphQL Ruby. And our approach looks something like this to use GraphQL Ruby. We wanted developers to be able to write one GraphQL query for all schemas. We took a look at the different ways that GraphQL changes might affect our app and came up with an approach to use GraphQL Introspection, allowing users to write one query for all schemas. From here, we would code gen separate GraphQL queries for each schema. This meant that one GraphQL query could turn into n number of GraphQL queries. In our case, one query for github.com, one query for GitHub Enterprise 3.0, one query for GitHub Enterprise 3.1. From here, we would then code gen one specific interface for any schema that our app supports, making building features for github.com and GitHub Enterprise quick and easy. This meant that product engineers only had to consume one interface rather than n number of interfaces or 3 different interfaces. Let's take a look. Let's try to visualize this pipeline a little bit and see how this might look. So starting with our GraphQL documents and all of the different schemas that we support, we built a tool with GraphQL Ruby to build what we call our GraphQL pipeline. Starting with a single set of GraphQL documents and multiple schema definitions, we can use GraphQL Ruby to begin to rewrite queries for each different server that we support. Using the results of GraphQL introspection and a little bit of ahead of time GraphQL AST parsing, we can decide which fields are supported by each schema before the code is ever run on our users' devices. However, this approach still leaves us in a similar place as before. If we execute Apollo against each schema, we'll generate 3 different sets of Swift files too, which doesn't make consuming these queries any easier for our product engineers. And that's where the last step comes in. Using a little bit more tooling, we created a Swift tool that parses the code generated by Apollo and creates one umbrella module for accessing any query for a given GraphQL server. This allows developers to consume only one interface rather than needing to worry about 3 distinct ones. Let's quickly illustrate this with an example. Let's take this query. Beginning with a simple query, let's say that users can only enable auto merge on github.com and only upload videos on github.com and GHES 3.1. Our query rewriter will use the introspection of each schema along with a bit of AST parsing to write out 3 separate GraphQL documents. The result is 3 separate queries, each of which are guaranteed to succeed for each of these different GitHub API versions. From here, we can execute Apollo's Swift code gen, which will turn our GraphQL documents into 3 separate Swift types and files that our app can then execute. We see there's a bit of duplication here, so let's see how we can fix that. To make this easier for our product engineers, our type gen then creates a generic anonymous interface for all three of these types, exposing optional values for those which might not be available in all GraphQL schemas that our app supports. This approach means that our team can create queries that work for any GitHub GraphQL API without needing to write explicit introspection checks at runtime. The end result is a much better product for our customers. This approach is still something that we're iterating on today, but we've found the results to be quite promising. Just another example of how GraphQL introspection can be used to build better products. So let's recap. We took a look at what GraphQL introspection is, which is looking within. We took a look at introspection at runtime, how we can execute queries to decide which features to enable or disable to prevent errors from our queries at runtime. And lastly, we took a look at introspection as an input to other tooling, how we might use GraphQL ASTs and GraphQL types to build type safety for all of our products. I want you to kind of consider these part of your tool belt. Don't reach for GraphQL introspection to solve every problem, but realize how you can use GraphQL introspection to build better tools and to build better products. If you want to learn anything more about what we talked about today, go check out these different links here in our slides. There's some really great tools that are out there to use GraphQL introspection and do some really awesome things. And I want to say thank you so much for having me today. It's been a pleasure talking. Thank you.
Thank you, Eli. That was really insightful. I enjoyed that. Yeah, and learning all about that, really taking a deeper look into it, and this was like the perfect opportunity. So I'll go ahead, and if there are any questions in the chat, I'll go ahead and forward them to you. But at the moment, they are none. Yeah, so far no questions for it. But thank you for your talk. It was very insightful.
Awesome. Thank you so much for having me, Alex. And I'm really looking forward to your talk as well.
Anytime. Yeah. Cool. I'll go ahead and take you off the screen, share my slides. Hopefully demo, and fingers crossed that that goes well. So yeah, so let's get started. In this presentation, we'll be talking about safe GraphQL API, Prisma, and Nexus, and it is split into three different sections: GraphQL schemas, and then the last section is Nexus and Prisma. So let's get started. GraphQL server is made up of two components: the server, or the GraphQL server, which is responsible for serving the API to your end users, and the schema, which is responsible for describing the shape of your data and all the operations that are going to go in it. And we'll take a keener look at the GraphQL schema, which is made up of two more things. It seems that this is going to be a list-oriented sort of talk, but what the rest of it has in store for us. So it's composed of type definitions and resolvers. The type definitions describe the operations and shape of your data, while resolvers are the actual implementation of your type definitions. So what would a GraphQL schema look like? In this example, we have two type definitions: the user type, which contains two fields, which is the type ID. The exclamation mark denotes that it is non-nullable, and the name field, which is of type string, that is nullable. We also have a query type with a user query that returns an array of users. It's important to note that each types have their own resolver functions that will be responsible for fetching and returning the data. So what I do like about GraphQL is that it encourages a schema-driven development that pushes you to think, understand the shape of your data, and then you can implement the functionality for them. So when you're working with GraphQL, there are two common approaches for defining your schemas. We have the schema first approach, in which you define your schema using natural language, which you'd have to, and in this approach is beginner friendly and fairly easy or easy to get started with. You can read it and you can understand it. The downside, however, is that it's error prone because you'd have to keep your definitions and your resolvers in sync, which can also be tedious and you sometimes difficult to debug. And the second approach is the code first. Of having your type definition separate from your resolvers, you would define the resolvers in the same spot as your code, which would eventually generate the schema or your well actions for you. So when adding database access to your graphic, you would have two schemas which you would have to keep in sync. The first one is the GraphQL schema and the database schema. Another challenge that comes up from this is that you would have to hide some fields that you wouldn't like to be exposed in your GraphQL schema, such as the passwords fields. So how would you manage them? So we'll cover a basic introduction of Prisma and what it is. And Prisma is a next generation type-safe ORM for Node.js and works with JavaScript and TypeScript. We have a Go version that is also in preview. It works with SQLite, MySQL, SQL Server, and MongoDB that is in preview. And Prisma has two value propositions to boost your productivity by letting developers query data in natural and familiar ways, and increase the confidence with type safety, auto completion, and a robust API. Prisma consists of three components, rather the Prisma client, migrate, and studio. Prisma client is if auto-generated ORM. Migrate, Prisma migrate is a declarative modeling and migrations tool, and it allows Prisma migrate uses Prisma schema changes to auto-generate fully customizable SQL with schema migrations. And finally, Prisma Studio, modern, intuitive, and easy to use graphical user interface for your database. So, out of Prisma, we have schema, which is a single source of truth for your database schema and application models. It's almost resembles the GraphQL schema, but it is not a GraphQL schema. Anyway, it enables intuitive and declarative data modeling and provides the foundation for type safety that Prisma provides. So in this model, we are going to have a user. The user model is the one that is going to map to a table name in your database. In this model, we will also have the ID field, which is of type integer, and the ID tag for getting the actual name right now is a primary key that will auto increment the value. And we'll also have an email field, which will be of type string and unique index. And finally, a name field that is optional and denoted by the question mark. So this SQL migration that would be generated on running Prisma migrate dev would be this exactly. And this will create a database schema in your database, and yeah, that it would map in your database. So let's take a look at how relations would be modeled using Prisma. So in this example, we're going to define a one-to-many relationship between the user and posts. It means that a single user can have many posts, or many posts can belong to a single user. A couple of things to note in this example is that the author ID represents a foreign key, and all posts in user and author in post are relation fields that are used to access the relations. They're not created, you can think of them as virtual fields because they're created in the database because only the author ID is necessary in this example. So with the relation defined, you can generate the following migration using Prisma, and you can do this using the Prisma migrate dev command. Is sorry for jumping too quickly, but this is this SQL that is generated based on the Prisma schema that we just did. So the following shows a Prisma query that creates a user to a related post. And as I mentioned before, Prisma provides two propositions: the auto-completion and the queries that are not classes to avoid modeling objects. The client exposes that return plain old objects. It provides a type sales query that can be validated at. So you may notice that the attempt to set the email to an integer, which immediately creates a type error, and this also clearly denotes you feedback using the. So, and with Prisma Studio, you can simply type npx Prisma Studio in your terminal to have a graphical user interface for your database that you can now create, edit, and rows in your data. So here, the example snippet shows you how you can related posts, edit a post, and create a new post that is also associated to that user. So, and the final bit is going to be merging GraphQL with Prisma. So it's a good time to introduce Nexus. What is Nexus? Nexus provides you a way to define your schema using the code-first approach in the Node.js ecosystem. Should also mention that Nexus isn't the only library that you can use. We have other tools like Type GraphQL Prisma and that are pretty good alternatives to this. So, but Nexus is just for this talk. Nexus is data agnostic, and you can use it with any data access layer and works with your GraphQL server of choice, whether that would be Fastify with Mercurius, Apollo, Express, Happy, name it, and it will be able to, should be able to. So when getting started with GraphQL, there's usually a lot of cognitive overhead to learn about the tool. So with the schema-first approach, you would have to rely on the tooling for each of these problems. So for example, some of the challenges that you may face is that you don't get the feedback when defining your schema. Like you may make a typo and it won't be picked up in the resolvers when defining a resolver, or you may make a field and in the resolver it's nullable. So this creates some inconsistency and sort of difficult to solve when using the schema first approach. So Nexus is type safe, as I mentioned out of the box, and I think I can go ahead and present a demo of how it works. Give me a moment to reshare my screen, as it's a live demo, hoping everything breaks. Yeah. So I'll go ahead and share the screen. So in this example, I will go ahead and stop the server and dev to start the server. And in this example, I have a mutation that is called a sign up user. And in this mutation, it returns it's of a non-nullable type that returns a user. I find a user up here, not exactly there. We've defined the user type that contains a few fields: the ID field, which is not nullable, the name that's nullable, that's not nullable, and also the post to denote the relations. So in our mutation, I made an intentional typo to call this email is not, the email field, which is from Prisma. The email field is a typo, and as we can see here, the property here, I think email is missing. I can't find error sometimes. TypeScript errors are a little verbose. So in this case, if I modify this to email, and which from the type safety from Prisma, it works. And we have a GraphQL server running. And this is sort of from the merger of Nexus and Prisma, where you get the types from Prisma that are also used when you work with Nexus. Nexus works is that it provides a make schema function. I'm going to jump to it. A make schema function that works in. Go ahead and stop screen and reshare my slide. So how it works is that Nexus has a concept called reflection. What this refers to is that when make schema is called, which was at the bottom when generating where we put together all the types and the GraphQL types and maybe TypeScript types, is that it generates a couple of artifacts. One is GraphQL schema, and secondly, it generates the TypeScript types that are picked up by VS Code and used for authentication and type safety. So I didn't show you the SDL file that is generated, but that is also created when you use Nexus. The make schema function is responsible for this. So sorry for the demo. This was a little disorganized. Sorry. So that was more. So you can also, when I changed the email field, I'm forgetting the name of the error that we made. The email field, email, the type error was resolved. You can go ahead a step ahead further and use Nexus Prisma. However, it's currently in preview and not completely complete. It's still in preview, so you can't really use it in production, but it would help you automate defining your GraphQL type definitions, for example, the post and the user. So that is the end of my talk. I will be happy to receive any questions, and I hope you found the talk useful. So, yeah. So do we have any questions in the chat so far? I can't see any yet. So yeah, and as we mentioned, we have had a raffle, and I'll go ahead and present the slides again for the raffle. Sorry, trying to get my screens in order. So sharing now. So, and the lucky winner of our raffle is Adesola Adeshina. Congratulations. We will get in touch with you with the email address you provided in the type form. And that is all. See you in the next meetup. Cool. We have a question. So how do Nexus and type GraphQL compare? So Nexus follows sort of like a functional approach towards defining a schema, while type GraphQL uses an object-oriented approach using decorators to define your schema, to annotate your schema. Yes. Any further? I hope that answers your question. Oh, thank you. Are there any further questions? Cool. That will be all for today, folks. See you on the next one.